PK 8012/DOM judge. So every team will be given username and password, and they can log into this link and they can submit their problems using 3 programming languages: C, C++, Java, and Python 3. One thing you should remember, you should take the input using standard input stream like C in, C out in C++, or scanf, printf in C. Similarly, for Java, you have system.out and system.in. So please do not use non-standard input and output functions. For example, some students do the mistake like they use some functions or they include the libraries of Windows. So that in that case, the system will not work. Our system, we have installed our system in Ubuntu using standard C, C++, Java, and Python 3. You do not need to read the data from file. You do not need to write down the data on file. You just need to input the data from standard stream and output the data on the standard stream. Please be careful. There is an auto judge system, so exact character should be matched. So if you have any query in your DOM judge username login, there will be a query module available. You can send the query to judges and judges will answer you. So you should read the instructions carefully. So today we have Mr. Suleman Kazi. He has a more than 3 years experience in Silicon Valley in machine learning, AI, and computer vision. He is currently working in Google as a software engineer. So I will ask Suleman Kazi to start his presentation now. Suleman Kazi, आप अपनी स्क्रीन शेयर भी कर सकते हैं और
Okay. Thank you, Dr. Masroor. Let me share my screen.
आप स्क्रीन शेयर करेंगे क्या?
Abhi, can you see my screen?
Yeah.
Okay. So, Bismillahirrahmanirrahim. Assalamu alaikum, everyone. My name is Suleman Kazi. Thank you to ICPC Pakistan, Dr. Masroor, for inviting me to speak here. And I can also see my batchmate, Adi Shaukat, and a few other professors who I learned from in GIKI. So the talk today is about end-to-end machine learning, going from prototype to a final production system. Before I talk to you more about what I'm gonna be speaking about, let me give you a brief introduction to myself. So I graduated from GIKI Institute in 2014, bachelor's in electronic engineering. And then I did my master's in electrical engineering from Stanford in 2016. I worked at a startup for a while, which was acquired by Google. And then I worked in several different teams at Google, mostly focused on machine learning and AI. So I've worked on both computer vision and natural language processing problems. And it feels great to be back at GIKI because I spent 4 years here and I fondly remember the university. So before, if you want to take notes during the slides, that's fine. But I will also be sharing the slides on my Twitter, which is twitter.com/sunwatground. And one more thing, so all of the opinions that I express during this presentation, they're my own and they do not represent Google or my current or former employers. Okay, so that being said, let me tell you a bit about what the presentation today is about and what topics we will cover and what topics we won't cover. So the presentation isn't really related to competitive programming as such. It's more related to machine learning, and we'll go over the high-level process of how you solve a problem or develop a new product using machine learning. Feel free to stop me at any time by raising your hand and asking a question. But I think at the end, we'll also have some time for questions. So it's up to you if you want to ask during the presentation or after the presentation. The other thing is that this presentation specifically, I'll be talking about machine learning, but the general concept applies to any kind of product development that you do that involves algorithms, so like image processing, signal processing, non-machine learning development. And so this presentation is more about practical production systems. So for example, when I was a student at GIKI or Stanford, most of the assignments that you would get or the projects that you would develop were less, real life and more academic or more, related to your final year project or your courses. But when I got into, real life and started working at some companies, I found out that production systems are kind of different from what you work on during your assignments, and the things that you focus on are also different, right? So I think in that sense, this presentation is useful for you. So when you graduate, inshallah, and go on to work in an industry, I think some of the tips and the tricks here will be helpful. And so this presentation is more geared towards, real life applied machine learning. So I see machine learning as two kinds, right? There's research, in which you do more of academic research. And then there's applied machine learning, where you actually apply the research to a problem. And the thought process and the development process for the two of them are very different. I previously gave a talk on the research side of things, like how would you approach a research problem in machine learning. Again, the slides I've shared on my Twitter or LinkedIn, but this presentation is going to be more about production machine learning and how you applied it to like a real life problem for a company or for a startup. Okay, that being said, before I start the presentation, I want to give you this one concept. I think if you get this concept and nothing else from the presentation, I'll be very happy. So you're not expected to remember everything that you see today and everything that you hear about today. So there is this concept called prosthetic knowledge, right? And I learned this term again from Twitter. Prosthetic knowledge means information that a person does not know, but they can access as needed using technology. So for example, I, during my work, often have to look at Stack Overflow or look up formulas or equations for things that, I don't have in my head. But that doesn't mean that they're not part of my knowledge. They're part of my prosthetic knowledge, right? So similarly, I think the same applies to this presentation. Like you're not expected to remember everything. The presentation has references. So if you forget, you can go to the slides, Google the term, and you'll see the concept explained in much more detail, actually, than I can go through in like the time that I have here, right? And one more thing is that a lot of this presentation is based on a book by Andrew Ng, who is a professor at Stanford, and he's also worked in a bunch of different companies. The book is available free online. It's called Machine Learning Yearning. I'll share the link afterwards. And so I think that's also like a good practical introduction to machine learning and how you can apply it, right? Okay, so that being said, if there are no questions up until now, we can actually dive into the actual talk or the actual presentation. Okay, so let me give you kind of the big picture approach first, where, for example, if your company has, or your personal project or your startup or whatever you're working on has a new problem that has to be solved using machine learning or using algorithms, right? So image processing, signal processing, audio processing, anything. The high level approach can be divided into these 6 blocks, right? And the 6 blocks, we'll go over them one by one in the presentation, but just to give you the names, they are problem definition, where you actually define what your problem is. Solution design, where you say, okay, I know what my problem is. Now I need to go and design the solution for it. The next one, data collection. So once you know the solution, you need to know how well it works and also train the machine learning model for it. So the next step for this is data collection. Once you have the data, you develop your model or your algorithm. Once you have your model or algorithm, you deploy it. And then after you deploy it, you monitor it for quality and performance. Right? So what I've told you is like the simple high-level process, which is usually more applicable when your problem is small and neat and clean, which doesn't really happen in the real world, right? So in the real world, it looks more like this, where if you go from one phase to another, you sometimes have to go back to the first phase. If you're at model development, you might have to go back to data collection, or you might be at monitoring and feedback, last phase, and you might realize, oh, the way I defined my problem, I could have defined it better. So you go all the way back to problem definition and, repeat the whole process again. So it's a whole lot of iteration, redevelopment, refinement. And this is, I think, the main difference between something like this, which you're more likely to see during your undergrad or your assignments and your projects, and something like this, which you're more likely to see during like a real production system, for example, during an internship or during your job and so on. So what we'll do is, now that you know the 6 big phases of algorithm development or machine learning development, we'll go over them one by one and cover some important points. So we're not going to talk about the theory of machine learning or the math or the equations or anything. This is more of like practical tips and tricks for your actual solution. So the first one in that is problem definition, right? So this is like a very important step, because everything that you see here after problem definition is based on what you do in this step. So all of your future work depends on how you define your problem. And so you have to be very careful about, how you set up your problem and define it. In fact, when I used to work at the startup I was talking about, our CEO used to ask us this question, like, what problem are you solving? Instead of coming up to me and saying, hey, Suleman, what are you working on? Or, and I would say, for example, I'm working on neural network, or I'm working on X, Y, and Z. He would say, what problem are you solving? And that kind of forces you to think about, what is it really that I want to do with it? That being said, in machine learning and algorithm development, there are some traditional problems or categories of problems that you can solve, right? And I think the first thing to do is to realize that the problem that you have or that you're solving, what category it falls in. And I think that's super useful, because if you know the category that your problem is falling into, you can read the relevant research and the relevant papers and look up what people have already done for that specific category of problem. So kind of like a literature review. And so, for example, in ML, if you're working with images or videos, these are some common problems. For example, image recognition, where if you have an image, you just say what category the image has. So for example, in this case, the image has sheep, it has a dog. The probability of a cat and a horse is very low. After image recognition, the second category you have in image problems is object detection, where in addition to saying like this image has a dog or a sheep, you also draw a box. So you say this image has a dog, but this part of the image has a dog, right? And then you can say, for example, this image has, can you see my mouse cursor? Or should I switch to the pointer? Okay, now I guess you can see it. So, and this part of the image has a sheep, for example. The next problem is then segmentation, which has 2 types. And there you go from saying a box to saying these are the specific pixels or the exact pixels where the sheep is. For example, in this case, the sheep are blue. And then the red pixels are the one where the dog is, right? So you see, as you go from image recognition to object detection to segmentation, the problem definition gets harder and harder, because in this case, you just have to output a category. In this case, it's a box. And in this case, you actually have to classify each pixel. Similarly, you have a whole bunch of problems with other modalities. So for example, these are the problems that you commonly see when you have images or videos. And then you can also have problems based on text, like sentiment classification. For example, if I say the sentence, I am very happy, is that a positive sentence or negative sentence? You can have text generation. So for example, you can have machine learning algorithms actually developing a story for you, or completing your sentence. For example, if you use an Android phone or in Gmail when you're typing, you sometimes see the autocomplete, where you type half the sentence and then it autocompletes it for you. So that's text generation. The other is question answering. So for example, this one is really fun actually, because if you have something like a Wikipedia article, you can actually have a model and ask the model questions about the article, right? So for example, if the article is about GIKI Institute, and you give your model the input, who is the dean of computer science at GIKI Institute, if that Wikipedia article has the answer, it finds the answer in the text and then gives it back to you. And then there's also translation, which is really famous, translating from one language to the other. The second category of problem is, or the third category of problem is audio. With audio, you have speech to text. So for example, whenever you talk to, Alexa or Siri or OK Google on your phone, that's using a speech to text model, or sorry, that's the audio generation model. And then speech to text is when you're talking to your phone and you see what's written as you're speaking. And then you have recommendation systems. So for example, if you have a user using Netflix and you want to recommend movies to them, or if you have like a website like Amazon and you want to recommend products to your users, that's where the recommendation problem comes in. And then you also have time series prediction. So for example, if you want to predict the traffic in Islamabad on a given day, or if you want to predict the price of stocks on a given day, and so on. And it's a very long list. And the purpose of this isn't to give you a comprehensive list of what the problems are, but more to show you that, there exists like a huge category of problems, and your problem, you can choose a category from these. And then, you can also change the category and you can be creative about it. And, your problem can be in two categories, or your problem might combine text and audio. It might combine images and audio. That's called a multimodal problem. So you can get creative, but these are like the basic categories of problems that we see with machine learning. So once you know what category your problem falls in, what you can do after that is to actually define, okay, now I know my problem, what can I do to solve it, right? And one of the best tests that you can do is if you have a very big problem, you can divide it into parts and solve it that way, right? I'll give you a concrete example in a bit, but the advantages of this are that debugging usually becomes a lot easier. If your problem is divided into two parts, you can, so for example, if this is your entire problem and you divide it into two parts like this, where you have subsystem A and system B, you can debug system A separately, you can debug system B separately, and they don't have to be like, a complicated problem where you're not sure what's causing the issues, where the performance degradation is coming from, and so on. And we see this in normal programming as well, right? You don't write your entire program into one big file inside the main function. You divide your program into, classes and objects and data structures. And this is the same object, the same concept applied to algorithm development or machine learning. A real example of this is this paper, which is called Faster Rcnn. And what this Faster Rcnn is essentially a neural network. And what this network does is this thing, which I just showed you, object detection. So this is a network where if you give it an image, it draws a box around objects in that image, and then it tells you whether that object is a sheep, a dog, a cat, a car, motorcycle, or anything, right? So one way to solve the problem is to just have one neural network that does everything, right? It draws the box, it classifies the box, it tells you where the object is, and it tells you what the object is. But the way that this paper solves it is using exactly this principle that I just showed you. So it divides the problem into two parts. The first part is the detection part, where you just draw a box around an object, right? And you don't know what's in the box. You just know that there's some object in the box. You don't care about, so the detector part doesn't care about whether the box has a cat or a dog or a car. And then it gives the output to the second part of the network, which is called the classifier. And now this part of the network actually looks at what's inside the box and tells you, this box has a cat or a dog or a car. And so you see, in this way, you've kind of simplified the problem, because now you can develop and debug your detector separately. You can develop and debug your classifier separately. And you can see, for example, if your classifier isn't, or if your model isn't performing well on some things. So for example, it can detect dogs very well, but it can't detect cats very well. You can see where the problem lies, like whether it can detect a dog or whether it can classify a dog. And that kind of makes it easier for you to focus on which part of the system you should improve and how you should improve it, which we'll get to in a bit. So that's the first part about problem definition. Any questions or comments here before we move on to the second part? Okay, if not, we can move on to solution design. So let's see where we are right now. We're at a point where we were working for a project, internship, company, whatever, and we had a problem, right? The problem can be we have a customer who wants to find out, where his cat is going, or we have a customer who wants to translate from English to Urdu or Urdu to English, or for example, we have a customer in retail who wants to predict what the traffic will be like on Eid, or what the traffic will be like during the summer vacations. And so you've classified that problem into one of those categories, and you've thought a little bit about, okay, how do I solve this problem? Can this problem be broken down into different components? And now you move on to the process for solution design. And so the solution design we'll talk about is very general. It might or might not be a machine learning solution, but even if it isn't, the concept that we talk about and the steps that we talk about still apply. So the first question you should ask yourself is, do you need machine learning, right? There are dozens or hundreds of problems, or even more, that can be solved without using machine learning, right? Don't use machine learning just because it's cool or everyone is using it or like another company is using it. Use it only if you need it. You can also use the more traditional, slightly older computer vision algorithms or image processing algorithms or audio processing algorithms like signal processing or Fourier transforms to solve a whole bunch of problems. And those algorithms are usually faster. And when they work, they can be more accurate, right? So the first thing you should consider is like, if you can get your desired performance that you want faster and also cheaper using those algorithms, you should use them. If not, then maybe consider machine learning. The second thing you should ask yourself is, machine learning, especially deep learning, needs a lot of data. So for your problem, if you can't collect a lot of data, there's a good chance, or find an existing data set, there's a good chance that your machine learning system will not work very well. And then the other thing you should consider is, so again, especially with deep learning, machine learning isn't very interpretable. And what I mean by that is, so for example, if you have a machine learning network and it classifies an image and it says there's a cat in it, you'll know that there's a cat in the image, but you won't know, or you'll have a difficult time knowing why the network said that there's a cat in the image, right? But if the network isn't working fine and the image actually has a cat and it says it has a dog, you'll have a harder time debugging why is it thinking that the cat is a dog, right? Whereas with those traditional algorithms, it's usually easier to debug. There are some approaches to making machine learning and deep learning more interpretable, but they're more, I would say, research oriented and not used very much in products. And this doesn't have to be mutually exclusive. Like, you don't have to say, I will use machine learning or I will use a non-machine learning approach. You can also mix and match. For example, you can combine an audio processing or a signal processing approach with machine learning. And especially with audio processing, machine learning problems involving audio processing, that's like a very typical approach where the first part of the solution uses like the spectrogram of the audio, which is computed using signal processing. And then that spectrogram is fed into a machine learning approach. So that way you kind of get the best of both kinds of algorithms. Another example where, I wouldn't use machine learning is in robotic arm control. So for example, if you have a robotic arm and you know the weights and the moment of inertia and the inertia of every part of that arm, you can get very, very accurate millimeter level control with traditional algorithms. And those traditional algorithms are simply matrix multiplications, which are very, very fast on modern CPUs and GPUs. And so in this case, like, I wouldn't say you need machine learning to control a robotic arm, because there exist traditional algorithms that do the job really, really well. And again, this is more for product. Like, if you're doing research, then fine, go ahead. You can implement a machine learning solution. You can find new networks which do this. But if you're implementing a product and you have a deadline and a budget, I would say stick to the traditional solution. So let's see where we are. So we defined a problem. We thought a little bit about the solution. We decided if we're going to use machine learning or non-machine learning or a combination of the two. The other thing that you have to think about are parameters which affect your solution, right? So a lot of parameters go into deciding what you should try and what you can experiment with. So for example, the first thing is the data, like what data can you access? Can you access images, video, audio, text, or a combination of the above? So for example, if you want to do like translation, right? So with translation, if you have audio of a person speaking, you can add that in. If you have video of a person speaking, you can add that in. If you only have audio, then your solution space becomes more restricted, right? In addition to the data, the other thing that you should consider when designing your solution is the resources that you have, right? What's the deadline that I have? Do I need to make a solution that will that has to be launched in a month, or does it have to be launched in a year? And that will greatly affect what you work on, how much data you collect, how much time you spend debugging, improving the model quality, and so on. The second thing to consider is compute, like how many computing resources do I have? Do I have 1 GPU? Do I have 10 GPUs? Do I have TPUs? Both during training, because if you have more GPUs, faster GPUs, you can train more models, you can experiment more, you can train bigger models. And also during serving. So for example, if you're training a model using a data center, lots of GPUs, but eventually that model has to be deployed on a microcontroller, right? So for example, if you're making a robot and that robot doesn't have a GPU on it, it only has a tiny microcontroller on it. It doesn't matter how many GPUs you have in your data center. In the end, the model has to be served on the robot. So that's something that you have to consider as well. Third thing is the budget, of course, which affects how much data you can collect, how many hours of compute you can buy in the cloud. And then the other important thing to consider is the goal, right? And I think this one is really important. And this one is one that people don't really think about, and that's the quality bar. So for example, if you're building for a solution where an 80% quality or 80% accuracy of the model is acceptable, you should work on your solution with that in mind. Like you should not try to design a solution that goes up to like 99.9% accuracy, because even though it's good, but if your solution can work with, or if the customer wants or the project wants 80% accuracy, and your solution will work with 80% accuracy, any time that you spend improving it above 80% is, in my opinion, a waste of time, because you don't need that. And if you do need that, you should define your quality bar so that the actual metric you're aiming for is 99.9 instead of 80. One good way to lower the quality bar is to have a human in the loop, right? A good example of that, for example, is if you're recommending movies to a person on Netflix, right? So one option might be just recommend the movies and get no feedback at all. The other option might be to recommend a movie to the person and then ask them why, like a thumbs up or a thumbs down or 1 star, 5-star rating, and ask the person to rate your suggestion. So that way you actually get some feedback about how you did, and you can incorporate the data back into your model. And that way, you can get good quality data about whether the recommendations you're making are good or they're not good. So these are like some things to consider when designing your solution for machine learning problems. Okay, so we have defined the problem. We have a rough idea of a solution in mind. We know whether we will use images, video, audio, or text, how much budget we have, how much data we can collect, and what's our quality bar. The next step is to move on to data collection, right? And for machine learning, data is the most important, or one of the most important things, because when training the model, like you won't go in and like tune the model by hand. The model will be as good as your data. If your data is bad, your model will be bad. If your data is good, your model may or may not be good, but if the data is bad, your model will definitely be bad, right? And so when you're collecting data for your solution, it's not necessary that you say, I have to do everything from scratch, or I have to collect data from scratch. There are a few different options you have to use as data sources. So for example, the first one is use an existing data set, and we'll go over these one by one. So this is the easiest and if you can find an existing data set that matches your problem, a lot of the resources that you need to collect data and label data are reduced by a lot. So for example, this is one site like google.com/data search. If you go to this, you can search for data sets for anything, right? So for example, if you want data sets for coronavirus, you click on, or you just enter coronavirus COVID-19 here, and you get a whole bunch of data sets. So for example, from COVID data in the United States, infection map from the University of Washington, and lots of other data sets. So this is basically the first thing that you would do. And you can also filter. So for example, when was it updated? Is it free? What the topic is, natural sciences, geosciences, and so on. And you can download the data and depending on the license, use it in your project. So when you're developing a machine learning solution, that's actually the first thing I would do. Try to find an existing data set that matches your problem. If you can't find an existing data set, or if you do find an existing data set and you find that it's too small to completely solve your problem, the second step is collecting your own data. And there are a lot of subcategories in this. So collecting your own data depends a lot on what data you need. Some data sets are easier to collect than others. So for example, if you need images of animals, they're relatively easy. If you need, for example, a data set for like space exploration, right? Like a data set of images of planets or images of rockets or anything related to deep space, like images of stars, that data set is a lot more expensive to collect. And so the size of your data set is essentially going to depend on what your problem is and how easy the data is to collect. Some commonly used patterns for collecting your own data set. Number one is web scraping, where you just write a web scraper to scrape websites that have relevant content, right? So for example, images or Wikipedia articles or forums talking about something specific if you're developing a natural language processing model. And the second one is crowdsourcing. So there are some websites, so for example, like Amazon Mechanical Turk or Crowdflower, which you can actually hire people and pay them to collect data for you. So for example, if you're collecting a data set about Zoom meetings, right? You can actually pay people to join Zoom meetings, talk naturally, record it, and send you the data. One piece of advice here would be to start small. And this is the same as with problem design, right? So if you spend like 4 months collecting your data set and then labeling it, and then you start training a model and you find out that, oh, the data set I collected, actually I should have done something differently, or the labeling I did, I should have done something differently. At that point, it's very difficult to change because you have spent a lot of money and a lot of effort on collecting that data. So what you should do is to start small, collect, for example, a few dozen samples or a few hundred samples of your data, train a small model, or go through the end-to-end pipeline and see if you need to change anything about the collection process or the labeling process. And that way, you start small, you iterate. And this usually, for example, for my projects, this usually takes a few iterations, right? I'll collect 100 samples, train a small model, go back to the data collection process, refine it and improve it, train another model, maybe do some more refinements and improvements to the data collection process, and so on. And remember the arrows that I showed you? So this is like the first part of that arrow where collect data, train model, collect data, train model, and also refine the process during this phase. Another good way of collecting your own data is to gamify it. And what I mean by that is to do it in a way that people will actually want to collect data. So a good example of this is this data set called Quick Draw from Google. And if you open it, what it actually does is it asks you to draw something, right? So for example, it says draw a rainbow. And then you go ahead and you draw a rainbow, and it tries to guess. And what you just drew also gets added to the data set, right? So for example, if I draw a mug.
Oh, I know. It's mug.
So this is a good way of getting data for free, essentially, because people like to play games. And if you gamify your data set, they'll collect it for you, essentially. The other option that you have, if, for example, collecting real data is difficult or expensive, what you can do is you can use synthetic data. So synthetic data is basically fake data. And there are a lot of papers. For example, there's this paper, I think from Apple, which uses, so what they were trying to do in this paper, they were trying to develop a model for eyes. So take a picture of the eye and find out what you're looking at, right? If you're looking up or down or left or right. And so what they did was they actually they made a fake data set using 3D models, using Unity or Unreal Engine. And then they used that data to train their model, which greatly reduced their data collection costs, but then they also get a lot more data. So for example, how many people can you collect data from, right? 100 people, 200 people, 300 people. With this fake data set or with Unity, you can actually create thousands of characters and collect thousands of hours of data for your problem. This is another example where they wanted to collect images of homes, rooms, and they were trying to estimate the depth from the image. And so what they did was the same thing. They just generated fake images of rooms using 3D modeling software and used that as their data set. Another good thing that you can do if you don't have a large enough data set is data augmentation. And so, for example, if you have images, a good way of doing that is just change the contrast of the image, change the brightness, rotate the images, and you get a lot more images. Similarly, in natural language processing, you can use language models to autocomplete sentences or find similar sentences. You might have heard of some of these popular models like GPT-2, GPT-3, BERT. And what these models can do is they can generate a lot of text. And so you can use the text that is output from these models as input to your data set. And there are other techniques as well. So for example, if you have a sentence, you can replace similar words in the sentence, right? So for example, if you have one sentence that says, I am sad, you can replace sad with unhappy, which is another word for sad. So for example, you can use a dictionary to find similar words which have similar meanings and replace them, right? So if you only have one example, which is I am sad, you can use I am unhappy, I am not happy, I am not joyful, and so on. And that kind of gives you more examples for free. The other category that we have in addition to using an existing data set, collecting your own data set, is unsupervised learning. So with unsupervised learning, what it means is that you don't need labeled data, and your machine learning algorithm can learn on its own from unlabeled data. So some examples of this is, machine learning models which play games, right? So for example, if a model plays chess, or if this model AlphaGo, which plays this game called Go, you can just, define the rules of the game and start two models which can play with each other. And in doing so, you get like hundreds of thousands of games of chess or AlphaGo or Ludo or whatever you want to train your model on. And you don't have to have a human sit down and play those games for you. So another good example of unsupervised learning. So this type of problem where a model tries to learn to play a game is usually called reinforcement learning. But you can also use the same approach of unsupervised learning for other problems, like for image problems or natural language processing problems. So for example, this is a good paper, which is called Learning Features by Watching Object Move. And what this does is, this is a segmentation problem. So you're trying to remember the image I showed you in the beginning, like drawing a box around a cat or a box around a dog. So they're trying to do the same thing, but they're using unlabeled data. And the way they're doing it is they're taking a lot of YouTube videos and they're just assuming. So for example, if you have a video, if there's something moving in that video, that thing is usually an object, right? So for example, if you have a video of a road, the moving things are cars. If you have a video of, for example, this dog here, everything else is still, but the thing that's moving is usually a dog. So they take the motion from the video and use that to label their data set and use that for training a model. The other option you have is to go multimodal. And what I mean by multimodal is that, for example, if you're training a model, which if I'm talking, it's trying to write out what I'm talking. So like speech to text model, right? One way to do it is you just take my audio, feed that into a model and get the output. The other way to do that, which this paper actually does, is use not only the audio, but also the video, right? So for example, if you have a video and you can see how my lips are moving, in addition to the audio, you can actually do a better job of trying to figure out what I'm saying. And that's actually how humans do it as well. Like if you're trying to listen to audio without having the speaker in front of you, or looking at the person who's speaking, it's usually harder to tell what they're saying. But if you're also looking at the person, and even if the audio is noisy or muffled, by the way their lips move, you can actually guess what they're saying. And similarly, the model can also learn to do that. So this is an example where this problem of speech to text is usually solved using only audio. But in this case, they came up with a new innovative solution, which uses both video and audio and thus improved the performance. So these were some general, I guess, tips about collecting and using data sets. The next thing which we'll talk about is model development. But if you have any questions or comments so far about data collection, feel free to raise your hand. Okay, if not, we will go on to the next part, which is model development. So to give you a recap of where we are, we had a problem, we defined it, we thought a little bit about the solution that we're going to design from the problem, what data we're going to use, like images, video, text, how we're going to break that problem down into smaller parts. Then we collected data. Of course, like I said, data collection, model development, and all these steps are iterative. But we're going over them one by one. So the next step now is actually developing the model, right? And just like we discussed with data collection, model development does not have to start from scratch. Like you don't need to start developing a model from zero. Similar to what we did with data sets, like I showed you the data set search tool, where you looked for existing data sets which solve your existing problem. You can also look for models which people have used to solve problems similar to yours. For example, if you're doing a translation problem, there probably exist a lot of different models that people have used to do translation, right? So for example, in the early days of machine learning, by early days, I mean 4 years ago, what people used for image problems was ImageNet. And nowadays, this is also transferred over to text. So for example, if you're solving a text-based problems, there are a lot of models called large language models or LLMs, which are a good starting point for starting your solution with. These are the names of a few of the models that are usually used. And at this stage, I would say, like at the beginning, don't worry about, so these models are usually very large, but don't worry about the size just yet, because there are some processes by which the model size can be reduced. So for example, if this model had 1 billion parameters or 2 billion parameters, it can usually be distilled down to a much smaller model with like a very small loss in quality. So at this point, your main goal should be finding a similar problem and a similar architecture that has been used to solve that problem, and taking that model and trying to use it on your own. One tip here is to try to build and fail fast. So the same thing I had with the data set, right? So initially just try to set up your system end to end, and don't worry about the accuracy or how accurate the model is going to be or what the quality is going to be. Just worry about setting it up end to end, because this helps you set up a pipeline and see if there are any obvious errors in the pipeline. So even if you have, for example, 100 samples of the data set, you can basically see if your pipeline is working or not. Because with machine learning, it's usually very, very hard. Once you have like a very large data set and the entire pipeline set up end to end, it's very hard to figure out if everything is working properly, right? And that's where this part comes in, where even if you have some error in your data or some error in your pipeline, the problem with machine learning is it will work even with those errors. And what I mean by work is it will work, but it won't have the quality that you could have gotten if that error wasn't present, right? And it will give you some output, and it might be somewhat good output, even in cases where you have a bug in your pipeline. So for example, this is a good example of what I'm talking about. So this person, there's a link to the article here. What this person was doing was trying to make a simple classifier for birds, right? And so he takes the image, he takes pictures of birds with his phone, and then he trains a machine learning model. But when he tried using the model, he found out that the model wasn't really performing well. And so what was happening was when the phone takes a picture, it takes the picture, but it also has some metadata along with the image, which tells the phone or Photoshop if the image should be straight or whether it should be rotated. And even if the actual image is rotated, the phone and Photoshop both show it the same way up. But when he was actually training his network, the network was seeing the image rotated. And that's why his accuracy was low. And he could not have figured it out unless he visualized, his data at every step of the way to see what was going wrong. Because otherwise it's very hard to debug this problem. Yeah, so the next step is you want to optimize with a goal in mind. And I think I talked a bit about this in the beginning as well. So for example, if your performance goal is 80%, right, which is right here, the initial performance gain from 0 to 80 or 0 to 60 is relatively easy. Like you just need to add more data or use a bigger model and you get to that point. But the last bits of performance, so for example, getting from 80 to 85 or 90 to 95 or 95 to 100 is going to be where you need to spend a lot of effort, right? So you spend a lot of effort, the performance gain is very small. So this is called diminishing returns. And so you should be smart about how much effort you want to spend to get how much quality, right? So for example, if you spend like 1 unit of effort here, the delta in performance is 60%. But you spend another unit of effort here, the delta in performance might be 5%, right? And so the goal should be a mix of product requirements and also engineering feasibility. And a good way to measure this is with machine learning models is how good a human can do it. So for example, if you're solving a translation problem, how good is a human at doing the translation? Or if you're solving an object detection problem, how good is a human at detecting those objects and images? And machine learning, modern machine learning, especially deep learning, can usually get up to human level performance in a lot of these. So that's like a good metric to say, okay, I want to be near human performance for a lot of these tasks. The next thing is to get a single number metric. And what I mean by this is, for example, if you're developing an algorithm or training a network, you can have different measures of accuracy, right? You can say, I will look at precision, or I will look at recall, or I will look at the sensitivity or the specificity of the network. And all of these, if you don't know, they're all measures of how good a model is. But if you're looking at these 4 things, one model you train might be good in 2 of these and might be worse in the other 2. The other model you train might be good in the other 2 and might be worse in 2 other metrics, right? And so what you should always do is you should look at one single number. So for example, if you have precision and recall, you should look at, for example, the mean of precision and recall. And that makes it easier for you to compare models, right? So if you have model A and model B, how much is the mean of precision and recall of model A, and how much is the mean of precision and recall of model B? And so you don't have to look at like 4 different numbers to see which model is better. Another good thing to do when you're developing model is balancing your data set. So for example, if you have a data set of cats and dogs again, right? And your data set has 100 dogs, but only 10 cats. The model will perform a lot better on dogs, but it won't perform as well on cats. And so since dogs are more common than cats, you should undersample dogs, right? So for example, what that means is remove 90 images of dogs, so you have 10 dogs and 10 cats in your data set. Or the other way around, copy the images of cats 10 times, so you have 100 cats in your data set with some augmentation, because otherwise the quality will go down. Or you can also design your model in a way where the loss is weighted, which means that the model gives more importance to being right on cats, but less importance to being right on dogs. And that's what a weighted loss means. And so this is also something you have to be very careful about when you're developing your model. And I think we have covered this before. Visualize your data at every point in the way. This is a good tool for visualizing your data. It's called the what if tool. And what this does is once you have a trained model, you can run inference using the model on your data set, and it gives you it visualizes the output for you. So for example, this is a model, right, which is trying to classify whether a person is smiling or not smiling. The images in red are all smiling, images in blue are not smiling. Now, if for some subset of images, your model isn't really working well, this tool can show you why it isn't working well, right? So for example, in this case, you can see, I don't know if you can read it, but it's also classifying the images based on whether they have eyeglasses or brown hair. So you might find out that your model does not work well when the person is wearing eyeglasses, or the model works very well for people with black hair, but not with people with brown hair, right? So this is a good way of visualizing why your model is working, why your model is not working well, or why it's working well. And it can find like cases where, so for example, if you find that your model is not working well for people with glasses, you can add more data of people who are wearing glasses to your data set. And that way you can improve the performance for that category. Okay, so now we're at the point where we have the problem defined, we have a solution defined, we have collected the data, and we have also developed a model. Usually, in your undergrad or assignments or projects, this is where you will stop, right? You have the model developed, you have the numbers for quality, and you submit it and you're done. But I think the next two steps, which mean model deployment and monitoring, they're something that are very important when you're actually deploying the model in real life. So before we go on to the next section, if there are any questions about the previous ones, let me know. Okay, if not, we can move on to the next part, which is model deployment. And what model deployment means is essentially, you have the model, but now your customer wants to use the model, right? Or you want to help your customer. So for example, if you develop a model which recommends movies or recommends books to a person, that model isn't of use to you on your computer, right? Your user actually has to have a way of accessing it, like you have to host it on a server or on a CPU or GPU and have the user access it through an app or a website or something. And so that part is called model deployment. So you have a few options. The first one is self-hosted, which means you have your own computer and your own GPU and it's like on your office or in your home, and that's where you're deploying the model. That's called self-hosted. And the second option is using a cloud provider. So for example, using Google Cloud or Amazon or Microsoft to host the model for you. So essentially, both of them have their pros and cons. With self-hosting, you have a lot of flexibility in what kind of GPU you want, what kind of computer you want to host it on. Debugging is usually easier because the computer is with you. Using a cloud provider is good because it provides scalability. So for example, if you develop like a filter for Snapchat or TikTok or Instagram, right? And suddenly it goes viral. And 10 days later, you find out that you were only expecting 10 users, but now there are 10,000 users. Like if you're self-hosting, that means you can't really scale up quickly, right? You can't buy 10,000 computers or 1,000 computers to host your users. With cloud providers, that becomes a lot easier, right? So you just configure your project and increase the number of computers that you need. And now your model is suddenly running on 1,000 computers. So scalability is a lot easier. And then a lot of cloud providers provide tools for model hosting and model debugging and scalability and reliability. So that becomes a lot easier. Some things that you do need to consider when deploying a model are, the first thing is load testing, right? So what load testing means is, if I'm deploying a model, I must have some sort of sense of how many users am I expecting? Am I expecting 10 users to use the model, or am I expecting 100 users to use the model? Will the model be, will they be sending like one request per second to the model, which is called QPS, or will they be sending 10 requests per second to the model? And that affects, how many CPUs you need, how many GPUs you need, how much RAM you need to handle it. And then the second thing you need to consider is redundancy. So what redundancy means is that, for example, if you're hosting the model in one place and that server fails or goes down for some reason, how many models do you need to host? Like, for example, you need to host one in Pakistan, one in Dubai, one in another place. So for example, if one region does go down, or for example, if you have customers in both Pakistan and Dubai, that model can be closer to your customer. So you don't have to have that additional cost or latency of sending the request to another country and going back to them. And essentially for both of these, it's a trade-off of cost, like how much you can afford to host your model on. Like if you have higher QPS, that means you need more GPUs and more RAM. If you want more redundancy, that means you need more computers and it'll cost more to host your model. And it's essentially a trade-off between cost, QPS, and redundancy for your model. That's it for the deployment part. And the other part that we have left, which is also very important, is monitoring and feedback. Any questions about deployment? I saw one hand raised, but I can't hear anyone. Rabia, do you have a question? We can't hear you if you do.
Excuse me, मैंने आपको unmute करता है. Asked to unmute. Okay, Rabia, Abid. Rabia, Abid, आपने आपको पहले unmute करें, then. Yeah, thank you. अब आप बोलें. Rabia, Abid. Please speak.
Okay, I think we're having some issues, so maybe we can keep the question at the end then, because I have time for questions at the end.
Okay.
So,
आप माइक्रोफोन का कोई मसला आ रहा है तो क्वेश्चन एंड में कर लेंगे, ठीक है? मैं आपको म्यूट कर.
Okay, so the next part is monitoring and feedback. And what this means is, okay, now you have a model, you have deployed the model is serving your customers, but your job doesn't end here, right? Because when you trained the model and you deployed it, you had numbers for the quality, you knew what the quality was on your data set, but you don't know what the model will do in the real world, right? Whether it be reliable, whether you'll run out of RAM or run out of GPUs, or whether the data will change, whether the performance will be lower. So a really important part of developing a product that uses machine learning is monitoring and feedback after deployment, right? So some of the common issues that you can see after deployment is, the first one is that real world data can be very different from your training data set. So for example, if you train your model using one image resolution, people might be using a different image resolution, right? So for example, if people are uploading data from their phones, different phones have different resolutions for their camera. And if you're not resizing the images, the model might be getting different resolutions. Or if you develop the model using, for example, data from one region, right? So for example, if you develop a model to detect cars and the data you used is from Europe, the roads and the cars and the infrastructure in Europe will be very different from infrastructure and roads and even the models of cars in different countries. So for example, for Pakistan, if your users are in Pakistan and your data set was from Europe, you might have a drop in quality when people are using it. Similarly, if, for example, you developed a model which uses audio, people might use different languages, or the microphone quality for people might be different, which means your model might have differences. And even if, for example, if you're developing a model which predicts traffic, right? The data for traffic can be different, but even if it's same, right? For example, if you deployed the model in Pakistan and the training data was for Pakistani traffic, but now suddenly it's 2019 and COVID came along, right? A lot of people are working from home and not going outside their homes, which means that the traffic outside is now suddenly very different. And this is called data drift. And you need to account for this in your model as well, right? So that's where deployment, monitoring, and feedback is very important. So these are the two performance issues that you can see after deployment. Another thing that you can do after deployment is to use real world data to your advantage, right? So for example, if your data set is very expensive to collect, you were only able to collect 100 or 1,000 examples, and you had to launch your model using that. Okay, fine. But now that people are actually using your model, they are sending data to your model, right? Which you can use for inference, but you can also use that data and add it to your training data set and help it and use it to improve your model. And this is even better if you have a human in the loop. And what that means is, for example, if you have a recommendation system that's recommending books to people, right? Like I said before, you can have like a thumbs up or a thumbs down or a 5-star rating, and you can use that as a label. So for example, if you recommend a book to me and I don't like the book and I give it a thumbs down, you can use that as a negative example for your model. Or if I give it a thumbs up, you can use it as a positive example for your model. And that way you can get additional training data for your model. And one good thing to do is similar to, I don't see the slide, I think I deleted it by accident, but similar to how you have unit tests for your code or integration tests for your code, like for example, when you write code, you write a unit test which tests the code. Similarly for models, you should have tests, right? And what the test does is two things. The first thing the test does is if you have a model hosted, it sends requests to the model at regular intervals. So you know that the model is working. And the second thing that the test does is it, for example, it uses your validation set to send requests to the model and then looks at the quality of the model. And that way you can see, for example, if you're uploading a new model or you're updating the model, that the quality doesn't drop. And that's called a serving test. So that's the part about monitoring and feedback. So we walked through very quickly, in fact, but like I said, I'll share the slides on Twitter and you can go through them. We walked through the 6 main steps for algorithm development and machine learning product development. And even if you, for example, if you remember what these 6 main steps are, I think that's also super useful, and you can always go and look up the details for them online. And for each one of these topics that I talked about in a few short slides, you can actually find books and lots of magazine articles or tutorials or blog articles talking about those. And so if you're interested, you can just search for them and look them up in detail. So that brings us to the end of the presentation and talk. And thank you once again to ICPC, especially Dr. Masroor, for inviting me and having me here. And I don't know if we have more time, but if we do, I can take questions. About this presentation or in general, yeah.
Okay, any questions from participants? Please raise your hand. मैं आपको unmute कर दूँगा. Okay, मेरे ख्याल से questions नहीं है. मैं थोड़ा सा ICPC के बारे में फाइनल दोबारा बता देता हूँ. Then हम ऑफिस में गुड बाय कर देते हैं. सलमान काजी, आपका बहुत बहुत शुक्रिया. आप इतनी रात को यूएसए से लाइव आए. मैं अपनी शेयर स्क्रीन कर देता हूँ. ये अफान अहमद, आप अपने आप को अनम्यूट करें और फिर क्वेश्चन बोलें. अफान, आपने रेज हैंड किया था. चलें, और किसी को क्वेश्चन है तो बताएं. मैं देखूं फेसबुक में, देख लूं ऑनलाइन. तो अली, अगर देखो फेसबुक में, मैं देखता हूँ कोई क्वेश्चन था. ओके, आई एम वेरी थैंकफुल टू सलमान काजी कि उन्होंने आधी रात को उठ के आईसीपीसी पे एक सेशन दिया आप लोगों के लिए. बहुत अच्छा इंफॉर्मेशन थी. इन्होंने बताया कि हाउ where we should use ML and where we should use normal algorithm. If we have a solution for using normal algorithm, obviously we should use simple algorithm is because those give you a solution faster and accurate. एंड उन्होंने माशाल्लाह बहुत अच्छी टिप्स दी मशीन लर्निंग के लिए, जो उनका एक्सपीरियंस था सिलिकॉन वैली में, कि आपने किस थ्रेशोल्ड को इस्तेमाल करना है, किस किस्म के ट्रेनिंग सेट्स इस्तेमाल करने हैं और कैसे डाटा बैलेंस वगैरह करना है। तो फाइनल में मैं आई वुड लाइक टू से थैंक टू माय स्पॉन्सर्स, स्पेशली एक्सिस मॉल वाले हमारे साथ नीचे आए हुए हैं, और उन्होंने कहा है कि स्पेशल डिस्काउंट फॉर जीआई के फैकल्टी मेंबर एक्सिस मॉल एंड अपार्टमेंट्स अवेलेबल है। कोई अगर आप लेना चाहें तो डायरेक्टली उनसे कांटेक्ट करके जीआई का कार्ड दिखा के आप उनसे डिस्काउंट ले सकते हैं। अगर कोई मसला हो तो यू कैन टॉक टू मी। एंड देन वी हैव टोयोटा फैबर ने नीचे एक टोयोटा यारिस का एक सैंपल भी लेकर आए हैं, आप लोगों के लिए चेक कर लें, और स्पेशल आप लोगों के लिए प्रायोरिटी बुकिंग देंगे और पेट्रोल टैंक भी आपको फुल करके दे देंगे। तो ये तमाम फैकल्टी मेंबर्स और तमाम कॉन्टेस्टेंट्स जो जीआईके में हैं आर मोस्ट वेलकम टू ज्वाइन हाईटी आउटसाइड कैफे, दैट इज कैफे लॉन, उसमें आप आके देख सकते हैं। तो आई एम not only thankful to Axis Mall and Toyota Faber, I am also thankful to Higher Education Commission Islamabad, Pakistan Software Export Board, Digital Pakistan, Tech Dusty Nation Pakistan, Airlift, Janai Team, UWorks, Noon। अब UWorks और Janai टीम का मैं बहुत ज़्यादा शुक्रगुजार हूँ, क्योंकि लास्ट 3 ईयर से ये मुसलसल सपोर्ट कर रहे हैं, और सॉरी पाकिस्तान सॉफ्टवेयर एक्सपोर्ट बोर्ड भी माशाल्लाह। तो अगर कोई क्वेश्चन है तो आई कैन टेक, मैं फेसबुक लाइव पे भी देख लूँ अगर कोई क्वेश्चन है, वरना फिर हम इस सेशन को सुलेमान काजी से लेके एंड करते हैं। फेसबुक में कमेंट सेक्शन में किसी ने अगर कमेंट की हो, नहीं मेरे ख्याल से कोई कमेंट्स नहीं है। ओके, मैं आप लोगों का बहुत बहुत शुक्रिया, और सुलेमान काजी का भी बहुत बहुत शुक्रिया। इंशाल्लाह ही विल बी इन टच और इंफॉर्मेटिव क्वेश्चन देंगे। सोहेल मलिक साहब का एक हैंड रेज किया हुआ है। सोहेल साहब आप रेज हैंड करें ताकि मेरे पास ऊपर आए, फिर मैं आपको अनम्यूट कर दूंगा। या प्लीज अनम्यूट योरसेल्फ एंड आस्क द क्वेश्चन।
Thank you, Dr. Masoor. It was a very good session. Basically, I'm mechanical engineer, Suleman, और मुझे बड़ी खुशी हुई कि you are doing a very good job. ज़्यादातर जो कंटेस्टेंट हैं वो स्टूडेंट्स होते हैं, तो आप अगर उनके लिए ये बताएं अपना सफ़र कि how did you join Google, because it's very good to know.
Sure. So मैंने JK से ग्रेजुएट किया था 2014 में, इलेक्ट्रॉनिक्स इंजीनियरिंग में बैचलर्स किया था। तो मेरा जो करंट काम है वो थोड़ा ज़्यादा सॉफ्टवेयर या मशीन लर्निंग से रिलेटेड है, लेकिन आई डोंट थिंक कि दो फील्ड्स हैं इतनी डिफरेंट हैं, काफ़ी ओवरलैप है इनमें। तो JK के बाद मैं मास्टर्स के लिए आ गया था यहाँ पे US में, वो भी इलेक्ट्रिकल इंजीनियरिंग में, और आई थिंक उसमें जो काफ़ी मुझे हेल्प हुई थी मास्टर्स में एडमिशन लेने में, वो ये था कि ऑल्दो मेरे कोई रिसर्च पब्लिकेशंस नहीं थी GIK में, पर मेरे प्रोजेक्ट्स काफ़ी ज़्यादा थे। तो जिस तरह आप लोग ICPC में पार्टिसिपेट कर रहे हैं, इस तरह ही जब मैं JK में था तो मैं मेरे दोस्त काफ़ी, हम लोग प्रोजेक्ट्स में और हैकाथॉन्स में इस तरह चीज़ों में पार्टिसिपेट करते थे। माइक्रोसॉफ्ट इमेजिन कप में हमने पार्टिसिपेट किया, शैली का मैराथन, और इस तरह की यानी फाइनल ईयर प्रोजेक्ट हमने उस पर एग्जिबिट किया इन डिफरेंट एरियाज इन पाकिस्तान। सो आई थिंक दैट रियली हेल्प अ लॉट। सो आई वुड रिकमेंड कि जिस तरह आप यहाँ पे आए हुए हैं और इसमें पार्टिसिपेट कर रहे हैं, या आपकी CV को भी स्ट्रॉन्ग करता है, आपके पोटेंशियल फ्यूचर एम्प्लॉयर्स को बताता है कि यू नो दिस पर्सन is interested in what he or she is doing, और क्योंकि again it's a competition, so if you win, you know, that's a plus point on your CV. So yeah, I think those are the main things that help a lot.
अच्छा, इसमें मैं एक और चीज ऐड कर दूं जो सुलेमान ने बात की है। देयर आर लॉट ऑफ कंपनीज जो सिर्फ ICPC के जो कंटेस्टेंट है सिर्फ उनको जॉब इंटरव्यूज के लिए शॉर्टलिस्ट करती हैं। इधर हमारे पास एक स्पॉन्सर है, दैट इज नून दुबई, और वो भी आप लोगों को शॉर्टलिस्ट करते हैं। नॉर्मली जो भी ICPC के, हमारे ICPC के बहुत सारे अलुमनाई पाकिस्तान से भी इधर जॉब कर रहे हैं, बाकी किसी को वो शॉर्टलिस्ट ही नहीं करते हैं। तो इंशाल्लाह आपके जो रिजल्ट्स होंगे मैं उनको शेयर करूंगा, दे विल कॉल यू फॉर द इंटरव्यूज। एंड देन अगर सोहेल मलिक साहब का कोई और क्वेश्चन है तो पूछें, देन आई विल गो टू अदर। ओके, एक एक हसीब अहमद, ओके आई आस्क, ओके हसीब साहब, एनी क्वेश्चन? प्लीज अनम्यूट, या नाउ यू स्पीक. हसीब, हमें आवाज नहीं आ रही. हसीब अहमद, आपकी आवाज नहीं आ रही, तो मैं फिर उतनी देर आपको म्यूट करता हूँ, आप अपना माइक्रोफोन चेक करें, देन आई विल टेक मीनवाइल अली शॉप.
Thank you very much, Dr. Masood. Thank you, Suleman. Long time no see. Nice to see you again. It was a very good talk.
Thank you.
डॉक्टर सुहेल मलिक और हमारे जो पार्टिसिपेंट्स हैं उनको मैं बताना चाहूँगा कि सुलेमान जो हैं उन्होंने एक और टॉक जो है हमारे साथ प्लान की हुई है. हम उसका सुलेमान की अवेलेबिलिटी के मुताबिक जो है इंशाल्लाह स्केड्यूल अनाउंस करेंगे, और वो उसका जो टॉपिक है वो स्पेसिफिकली यही है कि किस तरह से आप ऑर्गेनाइजेशंस लाइक गूगल, माइक्रोसॉफ्ट वगैरह में जॉब ले सकते हैं, और सेकेंडली उसमें जो हायर एजुकेशन है जिस तरह स्टैनफोर्ड, MIT और इस तरह हाई रैंक्ड यूनिवर्सिटीज़ हैं उनमें किस तरह आप मास्टर्स या PhD के लिए एडमिशन ले सकते हैं. तो ये इंशाल्लाह हमारी नेक्स्ट टॉक होगी जो हम सुलेमान के साथ मिलके स्केड्यूल बना के फिर इंशाल्लाह सब लोगों के साथ शेयर कर देंगे. थैंक यू सुलेमान. थैंक यू सर.
Thank you.
अच्छा हसीब, अब दोबारा आपको अपने आप अनम्यूट करें.
जी सर, आवाज आ रही है?
हाँ, अब आवाज आ रही है.
Yes, sir. Sir, my question is that you just asked that we just duplicate that data that is quite low. For example, the cat data in that data set is quite less as compared to dogs. So it do not create any kind of biases for the model.
नहीं, good
for the cat
question.
data set.
बहुत अच्छा क्वेश्चन आपका, and it does. So for example, अगर आप डायरेक्टली उसी इमेज को कॉपी कर लेंगे 10 times या 100 times, so of course अगर मॉडल वही इमेज देख रहा है बार बार, so it will develop a bias. So what you usually do in that case is कि आप उस इमेज को थोड़ा चेंज करके डुप्लीकेट करते हैं. तो फॉर एग्जांपल
Apply
आप
some filters, right?
डेटा ऑगमेंटेशन कर दी, अगर आप मसलन रोटेट कर लें या ब्राइटनेस कॉन्ट्रास्ट चेंज करें,
Right.
या सो डेटा ऑगमेंटेशन के साथ डुप्लीकेशन.
Right. Thank you. Thank you.
ओके एहसन, मैं आप अपने आप अनम्यूट करें. हसीब पहले अपने आप को म्यूट कर लें. मैंने हसीब को म्यूट कर दिया. एहसन, आप. वालेकुम सलाम.
Sir, can you hear me?
Yes.
Sir, I have a question. Can we get the recording of this session?
हाँ, ये फेसबुक लाइव पे आप ICPC पाकिस्तान और JK में हमने शेयर किया हुआ है. ये आफ्टर सम टाइम्स वो उसको प्रोसेसिंग करके उसको लाइव वो रिकॉर्डिंग भी शेयर हो जाएगी ऑटोमेटिक.
ठीक है सर, थैंक यू सो मच.
ओके, एनी अदर क्वेश्चंस? अगर क्वेश्चन नहीं है तो फिर आप लोग सारे कैफे लॉन पे आ जाएं. वहाँ पे एक्सेस मॉल का भी स्टॉल लगा हुआ है, टोटा खैबर का भी है. एक्सेस मॉल की एक एक्स्ट्रा चीज है जो कि फैसल टाउन इस्लामाबाद में मोटरवे के एंड में ये है, और इसका स्ट्रक्चर पूरा रेडी है. अगर कोई इशू हो तो आप उधर जाके विजिट भी कर सकते हैं. ठीक है, तो और एसन का अगर है रेस तो बताएं. और कोई क्वेश्चन है तो देन वी विल स्टॉप द सेशन. एसन आप हाँ बोलें.
Any questions, you can always reach out to me on LinkedIn या जहाँ भी सर्च करके. I'm happy to answer there.
अच्छा, ये एक और मैं काम करता हूँ कि सलमान काजी के जो लिंक्डइन के